and my fellow friends. My name is Li Zhen Ru, as you all know, and today I'll be talking about rainbow. And I'll be covering on what a rainbow is, how it's formed, and a few types of rainbows. Okay. Now, what is a rainbow? Do you guys know what a rainbow is? Okay, so rainbow is not actually a thing, and it doesn't exist in a particular place, but we can see it. So it's like a illusion, but not really. It appears only when sunlight and the atmosphere conditions are right and the view's position. So it depends a lot. And yeah. Okay, I'll go straight to how it's formed. A rainbow, you guys know how it's formed when there's rain and when there's sunlight. So when light passes through a raindrop, it enters the raindrop and then it will then bounce off the back of the raindrop, and then light will be refracted into 7 colors, which is the royal gibbet, red, orange, yellow, and then when it escapes the raindrop, it will spread out, and then it will be reflected into our eyes. Now, that is an example of rainbow. No, it's a bad example. Now this is a picture of rainbow. I took this picture with my phone, so it's kind of bad. And if we zoom in, we can actually see that the red light is on the outer part, and then violet is on the inside. This is because the wavelength for red light is larger, than violet light. Red light has 650 nanometer, while violet light is only 400. That means that larger wavelength means that it will be refracted less, while shorter wavelength will be refracted more. That means that if it's refracted more, it will bend. It will bend inwards. If it's refracted less, it will bend outwards. Not really. Refracted less means it will refract less. If it's more, it will bend curve even more. So that means red light refracted less, it will go outwards, and then more, it will tend to bend inwards. That's why red is on the outer side and then violet is on the inner side. Now, imagine there's a wall of raindrops, like a wall of water droplets. Okay, and then light is shined into the raindrop. Raindrop A, light shines into it, and then it will be reflected. It will be split into 7 colors, and then red light and violet light, it will like spread. Red light on top, and then violet light on the bottom. So imagine red light entering our eye, but the violet light does not, because it's being spread out. But we can still see the violet light. It's because water droplet A reflects red light into our eyes, while water droplet B on another position reflects violet light into our eye. So it's from 2 different raindrops into our eye. Something like, imagine red light from the lower raindrop, red light into our eye, and then violet light from the upper raindrop into our eye. So we can see that different layers from different water droplets. But since the water droplet is like very far away, we can't really see that. And this is a side view. This is like a 3D view. So it forms a curve. It's because of the angle. We can't really see rainbow from the outer part because the light is not reflected into our eye, it's reflected above our heads. So we don't really see it. So only specific angles will reflect the light into our eyes. So only this part shows. Now this is an example. These are pictures of rainbows. The top pictures, it shows a view when water is sprayed and then light shines across it. From above we can see that it forms almost a full circle, like part of a circle. It's because that we can actually see most. From above we can like see downwards, so we can see more of the rainbow. From below it's just an arc because it's not reflected into our eyes. Okay. This is the same picture, except if we zoom in, there's actually double rainbow. Now it forms when light is reflected twice. Now, when it's reflected twice, it means that the color will invert. As you can see, it's really hard to see. Red light is in the inner bank, and the violet is on the outside. So, yeah, it's inverted due to it's reflected twice. And it has a larger angle because when it exits, when it's reflected from the water droplet, it exits in a different angle, hence, and then that different angle is a larger angle. That's why it's on the outside. These are examples, pictures of double rainbows. I did not take those pictures. They're from the internet, and yeah. This is a full circle rainbow. We don't really see it because we have to view it from a very high altitude so that the land, the horizon does not block our view. Like, we have to look it from above so that we can see the whole thing. These are pictures, and this, I've seen this on Instagram. It's quite rare, as I'll talk more about that here. This is called a circumhorizontal arc, also known as fire rainbow. It's not actually a rainbow, it's called an halo, and it's formed when light is passed through ice crystals on the atmosphere. It has a very large arc. As you all know, arc, it's a curve. But in this picture, it doesn't look like a curve. It's more like it appears to be parallel to the horizon. It's because it has a very large arc where we can't even see it curving because it's just too big to see the whole curve. And it only appears when the sun elevation is around 58 degrees or higher. That means it's like, I don't know, like this. And there has to be high altitude cirrus clouds, and then with plate-shaped ice crystals. That means that it's like ice crystals, like snow, except it's with a hexagon shape. It only forms when there's ice crystal on the high altitude clouds. And the sunlight has to enter the ice crystals at a very specific angle. Back. Here's an example of the pictures. And this is the ice crystal I was talking about, and it's a hexagon. Light from the sun will enter, and then when it enters, it will bend. And then when it escapes, it will bend again. And then the sky is very large, so there's like a whole lot of ice crystals. So imagine when light goes through all of them at once, like it scatters across the sky, so it appears to be like that. And that's it. Thanks. That's all from me. Yes, sir.
Okay. Very nice graphics.
Thank you.
I just want to know the most basic thing. If you want to see rainbow, you are standing in front of the sun or behind the sun?
The sun has to be at your back, and then the water droplets or mist, whatever, has to be in front, which the light from your back shines across, and then you'll be able to see it in front of you. And one more thing is that people will not see the same rainbow as you see, meaning people from, maybe you're standing here and then you see a rainbow right there, and then another person will stand over there and then they will not see the same rainbow, they will see their own rainbow because of angles. Thank you. Yes, sir. I've heard of triple rainbows, but I think it's possible to get a triple rainbow, but I did not look up into. But in my opinion, I would say it's possible to get a triple rainbow if the light reflected out from the first water droplet enters another water droplet and then reflects again. So maybe we'll get triple rainbow. But I'm not sure. I'll look up into it. Thank you. Yes. Azizul?
Is it possible for if the density of the air were to change, will it affect the shape of the rainbow?
Density of the air, it doesn't really matter about the density of the air. It matters, the shape of the rainbow will always stay like an arc because light is reflected out from the water droplets and then reflected into our eyes, and then we can only see it from a certain angle. If the angle is not right, we will not be able to see it because the light is not reflected into our eyes. So air density doesn't really matter when it comes to shape. Yeah. Yes. Rainbow in deserts? Yeah. Do you mean? Can we see rainbow in desert? Well, rainbow forms when there's water droplets or something, water droplets or mist. So if but desert, it's kind of dry. So if there's water, if there's water droplets in the sky and then there's the light, yeah, we can see rainbow in desert. But if there's no water, then there's no rainbow. Any more questions?